Okay, I'm on the hook. First of all, how many people in here have restored or repaired TV sets before? Okay, all right, so you know how to use a soldering gun, you know how to do those kind of things. There's no point in wasting time on that. First thing, I would suggest anytime you do anything to a set, get a SAM schematic on that model. You can get them from all kinds of sources. Google, sometimes you can get freebies, but there's a guy called the Schematic Man, anywhere from $3 to about $8. He'll send you a complete SAM's schematic on the set. With that, you're going to know where all the controls are. You're going to have waveforms on it. I don't think I need this.
Yes, you do.
Oh, I need this? Okay. Hello? Hello? No, I don't need it. It doesn't work.
Unless you don't want the projector.
No, I don't care. Yeah, projector's good. The light's on. Yeah, the projector would be good so everybody in the back can see this picture.
There you go.
Okay? All right. There we go. Thanks. SAM, schematics. Important. Also, it gives you the layout where all the parts are, so you can pinpoint a part. It tells you all the values of the parts. You've got a schematic to see the circuits, and as you've done more than one set, you'll see characteristics of various circuits, vertical circuits, horizontal circuits, output circuits. You'll see the characteristics of those circuits, so when you fixed one of some particular type of thing, it's going to be a similar thing in another set of the same type of circuit. So it's an invaluable source, and when you're done, you know that you'll have a schematic on that set. If you sell the set, it's an added bonus to the person who buys it. You can sell the schematic or give it to them. Okay. What?
The way we got this laid out.
What should I put it under the table?
Well, the wire's not lost unless Max has a longer.
Okay. Anyhow.
We need something. Yeah, just audio, just video to.
Okay. So schematic. Now, some other things. Tools. Does anybody know what this is? The most valuable tool you can get if you're going to recap a set. Now, there are some people who like to get really technical. They want to drill the old cap out, insert the new cap into the old cap, and put it all into the set so it looks original. That's nice if you're a museum or you've got a display that you want to show someone an old set that looks like old but it's really new. Most people just take the old cap out and put a new one in. I never, ever try to put a new cap in where the old cap was. That means connecting it to a tube socket pin or a terminal board, because they'll fall apart sometimes. Or on a printed circuit board, the print will lift. I always cut the cap off as close as I can to the cap, and I take this tool and take my new cap and wrap it around the pin and pull it off, and now you have a nice hole, 3 wraps around the pin, slide it over the wire of the old cap, solder it on. You've got a good mechanical and electrical connection, and you haven't risked damage to any other component in the set. Yes?
What does that tool cost?
About $1,000 if I send it to you. You can make it yourself with a piece of wood and a nail. You just grind the head off the nail, and that works fine. You can also use a piece of coax. That's not as stiff.
You can use an old X-Acto knife too, works perfectly with a piece of a paper clip in it.
An X-Acto, oh yeah, okay. That's another one. To have a tool to wrap resistors and capacitors or anything you're putting into the set is very nice, because that way you know you've got a good mechanical and an electrical connection, and you haven't risked damage anywhere else in the set. Another tool. That's just an old paper wax-covered capacitor. I recommend that you find these in sets. Wherever you can find them, scrape all the wax off. Take the wax and put it on something on your bench, because it's great to hold screws with a screwdriver. You just stick it on the wax, stick it in the screw, you've got something that'll hold on, and when you're done with it, so what? Leave the wax on. And there's plenty of sources of wax because you're going to be replacing caps, and they're all covered with wax that are bad. What else? Let's see here. Toys. It's really great to have a signal source and a signal source to receive the signal. When the first time you start to work on the set, first thing you have to do is plug it in. I recommend using a Variac with an isolation transformer. If you don't have one, you're going to have to plug it in cold. The Variac, an isolation transformer is essential if you're working on a series string set that has no power transformer, because you've got a hot chassis and you can damage your equipment or yourself. So try to get an isolation transformer at least, and a combination Variac and transformer is the best thing, because then when you turn your set on, you can turn it on at a very low voltage and see that the filaments light up, and raise the voltage a little at a time, measure the B plus to see if you've got B plus, and at the same time you're saving yourself some trouble that you'll run into with a higher voltage, and you're conditioning the filter caps too at the same time a little bit.
You might want to add an ammeter too, just to watch the current as it goes.
That's another thing. If you've got one, have an amp meter hooked up to it. Again, if you've got the SAM schematic, you'll know what the current should be, and you'll see it as if it starts going high, you know you got a short somewhere. And of course, you've got to do something about that right away, because you can't run the set without it. And if you do have a short, you've got to look to where the short is. That's transformers, filter caps, most likely thing that's shorted, tubes. And speaking of tubes, does anybody check tubes in the set they're working on? Yeah. Well, I know too much to check tubes. Why bother? And I have busted my hump so many times working on a set knowing it's not a tube and find out it's a tube at the end. So check the tubes. Check them for shorts particularly. But if they're weak, okay, that's not so bad, but you don't want a shorted tube in the set because it's going to cause other problems in the circuitry. But anyhow, signal source. This is something that's made for telephone people. It puts out a 400 cycle tone, and it's a continuity checker. And what's nice about a 400 cycle tone is if you introduce that anywhere in the video circuit, you're going to get bars across the screen if the video amp and the picture tube and everything are working. So you've got a source that when you first turn the set on, you can go to the grid of the video amplifier and you can see bars on the screen with it. And I'll see if I can find that real quick and show you what it looks like. Video amp. This is 6K6, channel 5. Another thing SAMs will give you is a tube location diagram where all the tubes are. Video amp, video amp, video amp. Put 6K6 right in the middle. Pin 5 of the 6K6. Sorry about that. 8, 7, 6. 7, 6, 5. What happened here? I don't know where this RF energy came from all of a sudden, but I'm going to have to do this later for you. Now it's gone. Maybe it was just coming from this. This will also give you an audio tone that you can go through your audio circuits and troubleshoot that. And then this is the other half of the guy. This is just an RF pickup, and this you can go stage by stage in your audio circuits to see if you've got sound, and you'll be able to hear the sound in something like this. But it doesn't have to be this kind. It can be any kind of a signal tracer. You can buy them for almost nothing on eBay, which is just a little audio amplifier with a pair of clip leads on it. And for a generator, all you really want is a device that will give you a 400 cycle tone or something in that region, which will allow you to have bars on the screen of the picture.
Hey, Chuck?
Yes?
Just describe real quick, on a basic level, about like physically where you, to input signals, where you put the leads on the signal.
Okay,
Yep.
Great. For video signal, the grid of the first video amplifier, if there's more than one, that will be the strongest signal to the picture tube. You can start with the grid of the picture tube, but you really got to have a good size signal to get into there. Or sometimes if it's cathode fed, wherever the plate of the video amplifier, the final video amplifier is, at that plate of that tube, there will be a capacitor going to the picture tube. On the other side of that cap, that will be the weakest signal, but give you something there, and then go back stage by stage. This is assuming you have no video. If you've got a picture, you don't need to worry about that. And it's the same way with audio. Audio, you want to go for the maximum signal input, the grid of the first audio amplifier. Most sets there's only one, an audio amp, and then the audio output stage. You can also use this real quick in the vertical circuit. Feed a 600 cycle tone into the grid of the vertical output tube, and you're going to get some sweep deflection. It may not be much, but it'll be something, so you know that at least the output stage seems to work. Any other questions? Quick, as we go along, if you ask a question, I'll be happy to answer, because it's easier that way, and everybody else will answer it too. Yes?
I was curious, do you need to use rubber gloves to handle the tubes? Because somebody tells me your oils will cause a tube to overheat very quickly. Do you like rubber gloves or latex gloves to handle those?
I'm not worried about that. You got to worry about burning your fingers handling the tubes. There are little rubber cups that you can buy to put over the tube to pull the tube out, because they're hot. So you want something, a cloth, a rubber. Little tube pullers, they make them, I don't know if they still make them, but they're bigger on the bottom and smaller on the top. For miniatures, you use a smaller one.
I have another question. Somebody, when I started collecting with sets, somebody's a radio guy in Kutztown. He told me that I needed to power my sets at maybe 104 volts to 105, something like that. Even the Variac, I powered up.
Yep.
So he said that if I powered it lower, like 20 volts lower.
I would start up at about 50 or 60 volts.
Okay. So that won't damage the components.
No.
Tell me it's going to damage the components by powering it down like that.
No. No, that's not going to damage anything. As you go, then you can go up in stages, but start as low as, first thing you want to see is the filaments light up.
Yeah.
If the filaments don't light up, you know you've got no power coming through the power transformer. If it's a power transformer set, or if it's a series string, if there's no power transformer, the tubes are all wired in series like the old Christmas tree lights. So if you've got a series string set and you have no filaments and there's no power transformer, just check every tube until you find one that's got an open filament.
So say to operate at lower voltage, when I play my TVs, I play them like 100 to 105, and that's safe?
Well, let me tell you, all of these older sets were built when the power was around 110 volts. Everything is too high for them today. And if it's another thing on voltage, if it's a selenium rectifier set, if it has, you know what selenium rectifiers are? Okay. If it's a selenium set and you replace it with diodes, you're raising the B plus voltage far beyond what it was originally intended to be. That's not good. Of course, it'll give you a little extra sweep and a little extra high voltage, but it's harder on the set because it wasn't made for that voltage. So if it's a selenium set, it's also usually a series string filament set, 25 watt resistor of just 30 ohms, 20 ohms in series with it, or some old glow bars. The glow bars that are used in The degaussing coils on projection set, on color sets, one of those glow bars in series with the AC line will drop the voltage and also cushion the shock. When you first plug it in, it won't have such a surge. Little 3-inch pilots. Anybody work on those? Those things are 6AL5s blow like crazy, and sometimes the Kinneys, because you plug them in, the thing lights up like a Christmas tree the first light. Get the voltage down. And if you get the voltage too low, you're just not going to have as much sweep as you need or stuff like that. But too low is better than too high.
Is there something that can cushion the blow when you first power something on without dropping the voltage?
Somebody made a soft start.
Yes. Yeah, but I don't know whether you can still get them.
Limit the surge, I don't know.
It's a glow bar, basically.
Glow bar classified is still in business.
Yeah.
The guy was advertising, but it would limit the surge and then let the voltage come up to normal for operation.
Well, it's just a glow bar, really. And if you can get you want a glow bar that has maybe 10 ohms hot, something like that, and it'll start out with maybe 50 or 100 ohms, and as the set draws current, the voltage drops the resistance drops in the glow bar, and that's a nice thing. And as I said, if you can find old color set degaussing coils, the circuitry there used a couple glow bars, and one of them was about 10 ohms hot, I think, or something like that. And you can buy them also on eBay. You can buy old glow bars, get them out of a lot of series string sets. GE, for example, that they always had a couple glow bars in that set. Their series string sets. Okay. Before recapping a set, the first thing you really want to do is fix the set. Because if you recap a set that doesn't work, when you're done recapping, if it still doesn't work, you don't know if you made a mistake or the set didn't work. So always try at least to get a picture and sound, something on the set to let you know that this is what you got before recapping, and you should have the same thing or better when you're done recapping. Repairing the sets, if you're going to recap anyhow, find out where your problem is. Let's go circuit by circuit. Check through your sound circuits, see if they're working okay, video circuits, picture, sync. This thing keeps losing sync here. And circuit by circuit, if you see a problem, like say in a sync circuit, and it's not a tube, and you measure the voltages, again, have your SAMs and measure the voltages around the tube. If they look pretty close to right, but you got one or two that are off, look for a leaky cap. If you got grid voltage on a tube that should be 3 or 4 volts negative or something, and you got 20 or 30 volts positive or higher, look on the other side of the cap going to that grid, and you'll see probably 100, 200 volts. Clip it. Measure the voltage on the low end. If there's any voltage on that cap, it's bad. Change it. And as you go into these circuits, there may be 4 or 5 caps in a circuit, and if you change those caps, that'll probably get that circuit working. Now you got a picture, go ahead and do recapping. Resistors do change in value, but if they look good, they're not burned or something like that, they're probably okay. And again, you can measure them with an ohm meter. You usually have to clip one lead off to get anything accurate. Old IRC resistors, they really look sandy, like they're not shiny. Those guys, if they're above 100K, they're bad. And just measure them and replace them. I would not replace any resistors unless they're IRCs, old IRCs. I would not replace resistors that measure good and are not bad, because you don't know what you're going to be putting in. The other one might go bad, it might be bad. Resistors, it's hard to tell how old they are when you get them. Caps, you know you're buying. You should be only buying new Mylar caps. Don't use anything else, because with very few exceptions, they're going to last as long as the set lasts. And that way you're going to have a cappy set. Now I brought some bad caps here. My intention was to put them in and try to create some trouble. And let's try with this filter cap here. Oh, incidentally, in looking for circuits, video circuits, you usually find a few peaking coils. Peaking coils look like resistors with little coils wrapped around them. Sometimes they don't look like resistors, they're just little coils by themselves. So you can, even if you don't have a schematic, you can usually tell where the video circuits are because you see those peaking coils. Let's see here. What's that?
One of the other reasons you need a schematic is the TV may not be currently wired as you get it.
That's true. Somebody else.
Got in there and screwed it up.
It's a good point. Sometimes, you got vertical roll, and the vertical hold control won't hold it. So someone goes into the set and puts another cap across something or a resistor, changes the value of what it was originally to get it to work. And it works for a while until whatever was causing the problem gets worse. So as he said, you may wind up seeing components, and always look for new solder joints. Seeing components don't belong in that set. And if you've got a schematic, that'll help you get to the right point.
If somebody took out 2 or 3 caps at one time and didn't get them all back.
Yeah, I was gonna say, I usually sometimes.
There are some, that happens sometimes, but that's why I say look for solder joints, because if it's a production change, it's not going to have fresh solder joints.
Okay, at the same time, this set here, mine, when I got this 27 years ago, this was before we used Variac, so I plugged, no boom, good. Very non-linear picture.
Okay. Oh, out of the picture. Oh, I'm sorry.
Of course, the point that Chuck just made. At least the horizontal and vertical circuits in that set had caps that were never shown in the schematic. And a lot of
Look what that did.
a lot of weird values.
As he finishes his story, I'll tell you where it was. Yeah, at the filter cap, I just bridged it across the filter cap on the set. And incidentally, filter caps, anything within 25 or 30% is okay. Don't worry about if it's a 20 and you put in a 40, or if it's a 40 and you put in a 20. It doesn't matter that much. When you're finished, it's like nice to put the right value in, but anything works on a filter cap within even 50% range. You want to picture something? Okay. Okay. Okay, that goes to the height control. Look at the schematic and see where that is.
It keeps turning itself off.
Chemical size. Okay. That was a 10 mic filter off of the center arm of the vertical size or the height control, which is the control that is feeding B+ to the vertical blocking oscillator. And this cap is not completely shorted, but pretty bad. And that's what it did to the picture. Also, whenever you put a cap in anywhere and you take it out, discharge it. Can everybody hear me there? No, okay. Back to the high school. Okay, that cap was a 20 mic cap to the center arm of the vertical size or height control. And it is the voltage source for the vertical oscillator transformer. It goes to the vertical oscillator transformer, which goes to the plate of the vertical oscillator tube. And that's what that partially shorted cap did to the picture. As I then said, whenever you put a cap in and you're doing testing with caps, always discharge it. Because if you have it on a 250 volt circuit and you take the cap out and you grab a hold of it, you're going to get hit. They don't dissipate their voltage by themselves unless they're a very bad cap. So discharge it by just shorting it out to the chassis. And that's another good thing to start with. The first thing when you're checking a set that's simple, fast, and easy and won't hurt anything is to go around and feel the filter caps. If you got a filter cap that feels really warm or even hot, it's a shorted cap. And you better find out which section of that cap is shorted, if it's a multi-section metal cap, and replace it. But you can't bridge that to replace it because it's shorted. You're going to have to cut the end of it loose and put a new cap in. But other than that, you can go buy all these can filters that have 2 to 4 filters in one can. You could just go by with a 40 mic filter or something like that and just check go to every point on the cap and bridge the filter across it. If it corrects your problem, you know that filter was open. And then you can replace that. And it's simple. You don't have to disconnect anything except if it's shorted. And if it's shorted, it'll be hot. It won't be cold after 15 minutes of the set running. The filter can is going to be warm. Okay, now we're going to take just an old paper cap. I don't have a meter here, which I really should have, but I think this one, if I remember right, was a leaky cap, not a shorted cap. And we'll bridge it across someplace in the set. Okay. See, the picture got brighter. And that is next to a peaking coil, so you can better believe this is in the video circuit somewhere. I'm going to try to put it somewhere that's going to cause a little more of a problem than just a brighter picture. You know what? This cap doesn't appear to be bad anymore. I don't know.
Well, you don't need that cap. Now you don't need that one. Get rid of that circuit. Obviously you don't need that. Ah, that still works. Get rid of that.
Oh. This is in the sound circuit, and we don't have any sound on this set, so that's no good. This just shows how many bad caps you can have in a set and it'll still work. Wow.
The lead came off the cap.
Okay.
I don't know when that happened.
Okay. That upsets the sink pretty bad. And let's see where that was. Bottom view. Horizontal AFC circuit and sink clipper. So you see it did affect the picture, but it still was halfway decent. And that's why you recap sets, because that's not a problem that the customer might get really upset about, but it's not right. And if you replace that with a good cap, it's going to make it much more stable. Oh, another thing, high voltage. I hate to jump all over the place. I had a schedule here, but it just doesn't work. When you start, and I'm sorry it takes so much time in between, but if you're working on a set, it's going to take you time in between as well. If you have no raster, no picture on the set, you really have to start there because you can't really tell what's happening if you can't see anything. And no raster usually means no high voltage. So the first thing to check to see if you've got high voltage. Simple check, screwdriver with a good insulated handle off of the high voltage rectifier tube, not to ground, just to draw an arc into the air. Touch it to the cap of the 1B3 or whatever the high voltage rectifier is, and you should be able to draw an arc half an inch or something like that long. If you get nothing there, then go to the horizontal output tube, 6BG6, 6BQ6, whatever it happens to be. See if you'll draw a shorter arc there. Do not arc to ground, you just want to arc to air. And if you get nothing at either one of those tubes, you know that the horizontal output circuit is not working and you've got no high voltage because that's where the high voltage is generated. In most sets, there are exceptions. Some of the sets use separate RF high voltage supplies and some of the real old sets use brute force supplies, and I'll tell you about that later because you don't want to fool with those. So the next step in finding out why you don't have voltage, assuming you've checked tubes and everything first, and assuming if it's a horizontal output tube, you want to be careful when you remove the cap off the plate of that tube, because if it's been in there any length of time and you twist it a little bit, you're going to twist the cap off. You can resolder it back on, but it's a pain. Just be careful. If you have no high voltage, remove the damper tube. If you get a little high voltage when you remove the damper tube, the damper's purpose, its main purpose is to dampen the horizontal oscillations and create a problem where you have noise, vertical bars and everything in your deflection circuitry. But its real purpose in most sets is to produce what's called B+ boost voltage. The B+ voltage in the set comes from the rectifier, the power supply, and the damper circuit utilizes that energy to create usually about 100 to 150 volt increase over the B+ voltage, and that boost voltage is used to drive circuits like the vertical amplifier, vertical circuits, any circuits in the set, and it doesn't work until you've got that circuit working. So those circuits aren't going to work if you don't have the boosted voltage, the B+ boost. If you remove the damper tube and you get a little high voltage, there are usually 2 or 3 caps between the cathode and the plate of the damper. And they're in the horizontal circuit, linearity coil, the width coil, in that area. Those caps are shorted because you shouldn't have any voltage B+ boost if you pull the damper out. If you pull the damper out and you've got voltage, then those shorted caps are feeding voltage across. So, again, SAMs, measure the voltages. Measure the voltage of the damper. If you don't have a boost voltage difference between the cathode and the plate of the damper, you're not going to have high voltage. Measure the voltage around the horizontal output tube next, the horizontal oscillator tube. How many of you use a scope in working? Great. Look at the grid of the horizontal output tube. You better have a sawtooth waveform going into that grid. If you don't, nothing else is going to work anyhow. So you go backwards and find that problem. Also, if that is a problem, very often you'll see the horizontal output tube plates getting cherry red because they're not getting any drive. And so, but if you're using a scope, that makes a lot of things much easier because you can see waveform. You can go to, in the vertical circuit, you can go to the vertical oscillator. If you've got a decent waveform, again, SAMs, look at the waveform there. If you got it there and there's no output, simple thing like the output transformer could be bad. And again, voltage measurements, scope measurements. If you got good waveform, vertical output, and you still have no sweep, yoke. You know, that's the final thing in that circuit that's going to work, as the deflection yoke is bad. Let's change some more caps. Let's see if we can do something here in this horizontal circuit. I see what looks like these boost filters. I need a pair of needle nose pliers. Do you have a? No. Do you have any needle nose pliers in there?
Buried somewhere in there.
Yeah, because I don't like going in this circuit without something to hold this part except my fingers. Beautiful. Wow. I bought all these bad caps that somehow or another aren't bad.
Popped off. That one keeps popping off that lead. Yeah, that's your problem.
Yeah. Gonna make a liar out of me. All right. Let's go to another spot here. Obviously, it makes a slight change, but not enough to go crazy. I notice, I don't know, these caps are not bad now. Anybody got any bad caps? I noticed in this set there's a resistor here in this horizontal output circuit which is burned up, which probably means, let's see what pin it's on. Pin 8, oh that's the cathode of the horizontal output tube. No, it's not, it's a screen. Okay. There's a resistor here that is burned almost beyond belief, and it's the screen voltage of the horizontal output tube. And the set's still working great. The resistor has probably gone low in value because it's burned up, and it's not affecting it. So sometimes a component that looks bad doesn't really change much in the set, but you got to change it because it's going to be, it's eventually going to burn off and be open, and then the horizontal output stage won't work. Let me see if I can make 6K6 pin 3. 6K6 pin 3. Video output right here. Pin 3, 1. I was talking to you before about the generator that will cause bars. Because we got a video signal on here, it's not too noticeable. See those bars floating through the picture there? That's the output of this little tone generator going into the grid of the vertical output tube. Sync circuits. The way most sets operate is somewhere in the chain after the video amplifier, there's circuitry that comes down to a sync separator tube, and sometimes there may be several stages with noise gates and all kinds of other things. But basically, again, if you've got a scope, look at the waveform coming off, it goes into the sync separator. At the output of that sync separator, there should be just sync, no video floating around in it. If you've got synchronization problems, vertical, horizontal, or both, the first thing, if it's both, you got to look there as it comes into the sync separator, and the output of the sync separator, noise gate, or whatever other circuitry there may be, and find out why it's not working. Again, tube check, caps checks, voltage checks, scope checks. If you've got horizontal sync but no vertical sync, most sets have a couplate, a little device which consists of a couple of 001s and a couple of resistors that hopefully filter out the horizontal sync and just leave the vertical sync to go into the vertical oscillator. They go bad frequently. You can make one. Sometimes it'll show the value of them, sometimes not, but it's usually 001s, 2 001s, and maybe 22Ks or something like that, if anybody knows the value offhand, but that's generally about what it is. The idea is it's to strip off the higher frequency horizontal sync pulses and leave the lower frequency vertical sync pulses to get to the vertical oscillator tube. So if you've got horizontal but no vertical, look for the couplate, or if there's no couplate, you'll see that circuitry, which is couple of capacitors to ground and a couple of resistors, 3 resistors usually and 2 caps to ground. And that filters out the horizontal sync. If you've got vertical sync and no horizontal sync, and you go down to AFC, horizontal AFC circuits, and anything in between, there may be some different manufacturers call them by different names, but some kind of circuitry to couple the horizontal sync into the horizontal oscillator. And again, it's component checks, individual parts in those areas, check them, and if you have a scope and you know what the scope should look like, and again, the later SAMs usually even have waveforms, so you can look for that. Oh, B&K analyzers. Do anybody know what that is? Okay. There was a few of them on sale here. They usually run anywhere from $10 to $40. It's a flying spot scanner which produces a test pattern signal with an RF output that you feed into a set so you can provide a signal source. It also usually has a horizontal drive signal, a vertical drive signal, so that you can go to your horizontal output tube and feed signal from that analyzer to the grid of the horizontal output tube. And if everything is bad before it, it's going to give you some high voltage, some picture. They are an invaluable source to have because you've got a good video source, you've got drive signals for your vertical and your horizontal, you've got an RF source to feed directly into the antenna. Most of them work when you buy them. If they don't, it's some caps, some tubes. The newer models have a lot of transistorized circuitry in them as well. I'm not a transistor man, so those are a little harder to work on. But if you are familiar with transistor operation, you can get one of those. They really, a lot more bells and whistles on the new ones. And it's something, if you're going to work on more than 5 sets, you should have one of those in your house because it's just an invaluable. Right now, you know, there is no signal floating around in the air, and so you have to use something else, like a DVD player or something, which usually doesn't even have RF outputs anymore. So that's really a good source of signal to have. And once you've got one, you're familiar with what it looks like. Once you have it set up properly so that the test pattern that's shown is really round, you can use it to adjust the set to make sure that the vertical circuits are adjusted right.
Suncor also makes.
Sencor.
Suncor.
Oh, they do?
Yeah.
Yeah.
But
I'm not familiar with it.
Yeah. Oh yeah, the same kind of unit,
Yeah.
multiple signals and drives. You
Yeah.
don't want to get one that's too new. Get an older like a VA48 that still has the high voltage output drives to.
I see. Okay. Well, the B&Ks all have the high voltage. The B&Ks are all old. They all have those drive circuits. And the best one is the 1022, I think it is. I don't remember the number of it. But there was 3 or 4 of them on sale here. One very old one, the one that has the slide that goes in from the top. And also you can put, if you're doing color sets, you can put crosshatch patterns in front of the flying spot scanner and produce a crosshatch pattern. You can put a picture, you can put anything you want to in front of that flying spot scanner. It's just a slide. It's usually about 3x4 or something like that. You don't understand the video. Any questions? I think I've gotten pretty much everything that you really need to know, I think, about this. Filter caps, always suspect those first because they're easy to check. I can't help you much on transistorized sets because they got loads of filter caps and those things, and they're all bad. Yes?
You were going to say something about a brute force high voltage?
Brute force high voltage supply. That little Philco over there is one. High voltage supplies in all modern sets are what is called an RF supply. They produce high voltage usually as a result of the energy in the horizontal output circuits, and that's used in the horizontal output transformer or flyback transformer to then generate high voltage. Some sets, like electrostatic sets, have a separate RF supply, one tube and an RF coil with a bunch of windings around it to produce high voltage from that. Those are all safe. They can make you feel uncomfortable, but they won't kill you. Brute force supplies use 60-cycle transformer right off the power line with big filter caps and a rectifier to produce the high voltage. Those will kill you. I mean, that's really dangerous. So if you've got one of the older sets, that little Philco over there has, the earlier ones have brute force. They were changed later to RF supplies. A lot of old Dumonts. The Dumont, what?
The Philco 48700 got a brute force panel.
Yeah, okay. That's...
Dangerous than working on a microwave oven.
What?
It ain't no more dangerous than working on a microwave oven. Just have to treat it about like the power supply.
Yeah, but with the microwave, you know what you're dealing with. You know that's a brute force supply. But usually you're used to high voltage on ordinary TV sets, and you've been zapped a few times and it hasn't hurt you. Well, you get one of those. If you see the high voltage is being generated from a power transformer and a big rectifier, big filter caps, dangerous. Watch it very carefully. I was always told to keep one hand behind your back. That helps, but it's no guarantee. because if you get it across here, both hands, very dangerous. And if you've got one of those sets, you just have to be careful.
I'm still very new to this, and I was kind of curious. What is the account for the great weight of these old sets?
What?
The great weight. I mean, I haven't figured it out. The weight is that the CRT or the chassis? Because you've got
Power transformer.
power transformer.
Power transformer is heaviest. The tubes, as you get bigger, they're heavier and heavier. Unless they're metal shell tubes, they're not so heavy. But you know, it depends on the. I got an old Philco radio that I just finished from my own radio, a mystery box radio. That chassis is heavy. It's unbelievable how heavy that is. A thick, heavy metal chassis. So, but as he said, power transformers, bigger they are, the heavier they are.
That's why a Pilot 37 is so light, because it doesn't have a power transformer.
No power transformer. Yep. Yep. Anything else you want to express? If you've got some ideas that I've left out, tell everybody here. No? Yes?
The thing that trips me up the most is make sure your signal source is actually producing the correct signal. That caught me up for 2 months. I was keeping modern television and take my signal source occasionally and plug it into my modern television to make sure it still looks like it should look.
Here's what happened with this set when we set it up here. The signal source was a DVD player with a modulator on it. And it looked terrible. The picture was bad sync, and it was washed out. And I said, oh man, there's trouble in this set. And Steve said, let's get the signal coming in from my system here with the program on it. And we hooked it up, it was perfect. That's a very good point, because if you don't know what, that's why I like that B&K thing. Again, if you've got something like that set up, you know from previous use that that signal source worked. And if it doesn't work all of a sudden, you can, as he said, check it by hooking it up to an ordinary TV set.
I have like a little 13-inch TV.
So you keep that in you keep that in your service area.
I keep that in my bench.
Yep.
That's the only reason it's there.
Right.
I just wanted to thank you for being so willing to reschedule so more of us could attend today, because I know it was originally scheduled for Sunday. And thanks for the interview you did was working. The way you threw out his knowledge was education. You just saw that.
That was a real thrill for me, I'll tell you. I like inventors, always have. And I try to follow them. I have a great radio interview I did with von Ardenne, the guy who really developed the first multi-purpose tube in Germany. And inventors have a mentality that's always been interesting to me, in that, and Zworykin was a very good example. He would discuss a subject that there was no technological reason for it to exist. We talked about the AAA triptychs, and he wanted to make a thing in the car that had a picture tube, and it would show where your car was and show where you were going, and it would move along. There was no GPS then. We're discussing this. There's no GPS. None of that existed. But inventors don't care about what exists. They care about where they see technology can take you. And they'll figure out how to make it work. But they say, oh, this is a good idea, I want to do that. And that's a mentality that doesn't exist as much today, because inventors are not people much anymore, they're teams. There's got to be tons of people involved, there's a lot of software involved, there's a lot of things that you have to know that's not a one-man thing. So that kind of stuff is gone. And there are a lot, I was listening today with a gentleman who's here now, and another person, I can't see if he's here now, but they were talking about their experiences in broadcasting and other stuff they were doing. I said, gee, these guys got to be interviewed. Someone's got to talk to these people and find out what made them work. Why did they go through that path? And what did they learn because of it? Because that's gone. Anything else? All right, now, there's free dinner for everybody who was here. Oh, I forgot where it was. All right, thank you very much.
So when you're I just recently acquired and restored a B&K 1075.
Oh, great,
So,
yeah.
and it works great.
Oh, that's fantastic.
So,
Okay, everyone,
so when I'm
the
inputting a
silent
signal,
auction is
it's
gonna
always
close
on the
without
grids
warning.
of the video tubes, right?
About 6
So
o'clock.
it's chassis
So,
ground and grid.
Grid, right.
Urge you
Right,
Yep.
to
Now, and usually,
the item
to be
you're interested
safe
in,
when you're
put
going
your
into
final
grids,
highest bid
put a
in.
cap between the output lead and the grid.
You don't know
What video? What value about?
Doesn't matter, 05, 01,
Okay,
something.
yeah.
What you want to do
bypass
is,
cap, right.
sometimes in the circuitry, particularly when there's stages of video,
Yeah.
the second stage of video may have the plate voltage of the first video on it.
I see. So you're
You don't want to back
Also,
that into the
anybody can
B&K.
fill out an
So,
evaluation
so the
sheet
cap
for
keeps it from backflowing.
the cap keeps allows the signal to go through, the voltage not.
Right.
And so if you do that, you're safe. Now it may attenuate the signal a lot,
see.
but if you do that and you see something and you want to get more, measure the voltage. If there's no voltage there, you can then hook it up direct.
Now, sometimes, and it may just me being confused, but some of the tubes that are used in like the video stages, do some of them have like 2 grids?
Oh,
Maybe
multiple.
right. Multiple grids.
Multiple grids
How do you
on.
know which pin? to
Okay,
insert the
all
signal
right.
in?
Again, Sam's.
Yeah, yeah. Okay,
All right,
great.
here's what
your
you-
video stages here.
Okay,
right.
no, this is the video IF stages. This is RF.
Oh, I'm sorry. All right.
Okay, here's your video stages here. Right after the video detector, here's video amp, cathode follower, video output.
Okay.
3 stages.
Yeah, I see it.
Okay, now this first stage. The grid that's next to the cathode
Yes.
is the control grid.
I see.
That's the grid that the signal is fed into.
I see.
The next grid up is usually what is called the screen